This is the Electricity Homework Booklet, question 4. A teacher wishes to construct a 2 ohm resistor from a metal wire of length 0.94 meters. The metal wire has an electrical resistivity of 4.9 times 10 to the minus 7 ohm meters. You are asked to calculate the diameter of the wire. Notice there are 4 marks allocated to this question. This is because of the complexity of the mathematical rearranging required, and also the need to be careful and distinguish between area and diameter. So from the datasheet you can get the equation for resistivity, resistance times area divided by length. Rearranging that equation leads you to an expression for the area. Now you just need to carefully substitute the 3 values given in the question, and then you can rearrange this to change from a value for area to the corresponding radius. The final step is then to convert the radius that you have found to a diameter value by multiplying by 2. All this leads you to an answer of 0.54 millimeters. This answer would get you all 4 marks. However, if you were to make a mistake, it's possible to pick up marks along the way. On the mark scheme, there was a mark awarded for this substitution. Secondly, there was a mark awarded for a value for the area calculated using this, which was 2.30 times 10 to the minus 7. Next, there was a mark for the radius, and then finally all 4 marks for the correct final answer. Notice I didn't calculate a value for the area. Had I made a mistake at this point, I would have therefore lost the second area mark. Next we move on to question 5. State what is meant by a superconducting material. This is a material that has no resistance below a critical temperature. I have taken these words from a mark scheme, but I would suggest that it's generally safer to say below rather than at. Part B. State an application of a superconductor and explain why it is useful in this application. So here's 3 possible examples you might wish to use. You could refer to MRI scanners, a maglev train, or a particle accelerator. All of these rely on the fact that a superconductor could be used to produce a strong magnetic field. The word strong is important here. In terms of understanding the significance of this, it's quite simply that a superconducting material with 0 resistance will enable a very high current, and a large current within an electromagnet will generate a very strong magnetic field.